Okay. Same problem, but this time you want to find when the volleyball is 7 feet above the ground and how far it is from where it will land when it's 7 feet above the ground. So, since the trajectory of this volleyball is a parabola, meaning that the volleyball would be like this, and then it would go down, there will be 2 points where it's 7 feet. So, for example, if this is 7 feet, it will be 7 feet here and 7 feet here. And we want to find the 2 points. And to do that, we want to, since they're asking to find when, we want to find the time. So the vertical component of the vector will be the formula we will be using to solve for time. So 4 plus 46 sine 28t minus 16t 2j. Okay, and we want to know when the volleyball is 7 feet above the ground. So we don't need j. It will be 7 because this is the y and this is whatever this is. Okay, we want to find it when the y is 7. So same thing, quadratic formula, but with quadratic formulas, the equation has to be equal to 0. So to do that, we will subtract 7 on both sides. 4 minus 7 is negative 3. So we then have negative 3 plus 46 sine 28 t minus 16t squared. Now you want to solve for t. Then we'll be using our quadratic formula again. So 0 is equal to, with our quadratic formula, a will be equal to negative 16, b will be equal to 46 sine 28, and c will be equal to negative 3. Okay. Negative b, 46 sine 28 plus or minus square root of b squared, and I'm just going to write it 46 squared times sine 28 squared minus 4ac. A is negative 16, c is negative 3, over 2a, okay, which 2a is the same as negative 32. Okay, now we are going to calculate this. So negative 4d6 sine 28 plus 46 squared times sine 28 squared minus 4 times negative 16 times negative 3, all that over negative 32, you get 0.1572. Okay, so this would be the first time where it reaches 7 feet, so on its way up. Now we want to find the second time. So remember when we did this, we did add instead of subtract. Now we're gonna do subtract to find the second time. So go back to your equation and then change this plus into a minus, because negative b is plus or minus square root. Okay, so for minus you get 1.1924, which is around 1.192. Okay, t1, t2. So this, when is the volleyball 7 feet above the ground? when it's 0.157 seconds and when it's 1.192 seconds. Okay, now to find how far it is, where it will land, from where it will land, we are going to subtract the horizontal component from the range. So this is the horizontal component. 46 cosine 28 t. And this is the range. Minus 61.533. Okay. But when I say subtract horizontal component from the range, this is the wrong way to format it. So it would be like this. 46 cosine 28t. And then you solve for t. So plug that into a calculator. 61.533 minus 46 cosine 28 t. Well, we're not going to solve for t because we know the time. So plug in for this time. Times 0.157 and you get 55.156. So this would be how far? 55.156 feet. This is how far the ball is during 0.157 seconds. And to find the other one, instead of multiplying it by 0.157, you're going to multiply it by 1.194. 192, excuse me. You get 13.119, so 13.119 feet. This would be where it is at 1.192 seconds. So this is the answer for the first part. This is the answer for the second part.